Okay, 514 skill check. Problem number 1 has to deal with the counting methods. So I know my counting methods are tree diagrams, area models, fundamental counting principle, permutations, or combinations. So in this problem number 1, I'm going to use the fundamental counting principle because I know that I either have a sweatshirt or short sleeve t-shirts. So my first choice, I have two different options. Remember, we always multiply. My second choice is I have the print, and I can have the print in white, gold, or dark blue. So I have three options for that. And then my last choice is the graphic. So my graphic is either going to be an eagle, Kennedy High, JFK just full of knowledge, or JFK the best place on the planet. So I have four different options there. So if I multiply all this together, 24, I would probably do the long sleeve t-shirt with gold print and JFK just full of knowledge would be my choice. Problem number 2. A lock needs 5 numbers entered in the correct order to open. The numbers used for the lock are 1 through 15 and cannot be repeated. So there's 15 different numbers and they cannot be repeated. The order does matter, so this must be a permutation. In fact, there's 15 numbers to choose from. I need to pick 5. Therefore, the answer is 360,360. Ooh, what a neat number. Cool. The other way of doing that is 15 times 14 times 13 times 12 times 11. And you get the same answer there. Problem number 3. Tommy wants to select 3 different stuffed animals to take on a trip. How many arrangements are possible? If he has a total of 34 animals. So in this case, the order does not matter. It doesn't matter which order he picks them in. They're all going on the trip. Combination. He has 34 stuffed animals. He needs to pick 3 because that's all that'll fit in his suitcase. So when you type that in your graphing calculator, 5,984. If you have any questions on this, please ask myself or Miss Brown. Okay. Alright, problem number 4. This is a cool way to do grades. Would you do this? No work would be required. It's just a just a matter of luck. Grade policy has changed. For your grade in math, you'll get to spin 2 spinners. The first spinner is divided into 5 equal sections, A, B, C, D, and F. The other spinner is divided into 3 equal sections. Keep spinner grade 1. 1 grade less than spinner 1, or your grade is C regardless of what you spun in spinner 1. I could draw them out, but I think what I'm going to do is I'm going to make an area model since I have 2 different spinners. My first spinner is divided into 5 equal sections, an A, a B, a C, a D, or an F. Okay, and then my other spinner is, you get to keep, you get to -1 grade. I'm just abbreviating here. And the other one is you get a C no matter what. So I can fill these in. I think the most obvious one is probably the C. The keep. Keep's pretty easy. A, B, C, D, F. The other easy one here I'd say is the C, where it's a C no matter what I spin in the first one. And then the -1. So if I spin an A on my first one, I get to subtract the grade, so that'd be a B. If I get a B on the first spinner, I subtract 1, that'd be a C. If I get a C on the first one, I subtract 1, that'd be a D. If I get a D on the first one, I'd subtract 1, that'd be an F. And if I get an F on the first one, I'd have to go 1 grade lower. Well, you can't get any lower than an F, so I guess that would have to stay as an F. So now I can fill in my probabilities. Probability of getting an A. Well, you can see there's 1 square that has an A out of a total of 15. So that'd be 1 out of 15. Probability of a B, it looks like there's 2 B's out of 15. Probability of a C, there's 1, 2, 3, 4, 5, 6, 7 out of 15. Probability of a D, well, there's 2 possibilities out of 15. And probability of an F, it looks like there's 3 probabilities out of 15. I don't know about you, but I think I'd rather go through the work and try to get a grade, because the probability of getting an A or a B is not very good, and I think that's a grade I would be striving for. When flipping 2 coins, what's the probability of both of them landing heads? The most popular answer was 1/2. Well, incorrect, people. I would need to draw out a tree diagram, or I could draw out an area model. I have my coin 1, which could be a heads or a tails. I have my coin 2, which could be a heads or a tails. So what's the probability of both landing heads? Well, I guess that would be this one right here, heads, heads. So I have a 1 out of 4 chance. Now we've seen this problem a couple times before. Should have been able to get that one correct. Alright, next one, expected value. Some of us are still struggling with expected value. When playing Dang Nabbit, a player rolls the die. If the number is even, the player earns 0 points, which is good because the object of this game is to get the least amount of points possible. If they spin a 1 or roll a 1, they earn 1 point, a 3 earns 3 points, and a 5 earns 50 points. And getting a 5, that is the Dang Nabbit. What is the expected value per roll in this game? Well, we take the outcome. I can get 1 point as an outcome, and the probability of that is 1 out of 6, plus I could also get a 3 in this game. Probability of that is 1 out of 6. Plus, I could also get a 50 in this game. That's the worst one, and there's a 1 out of 6 chance of doing that. So when you do the math, type it in your graphing calculator, you will come up with the expected value of 9. Alright, moving on to the next one. 7. Most of us are doing pretty well at this. There's only a handful of us that are struggling. In this case, we would do